So in this tutorial we are going to implement our doubly linked list, and we are going to implement these functions. So let's open the C-line IDE, and the first thing that we are going to do is we are going to create a node structure. First we will add the three variables in this node structure. One is the data, then the next pointer, and in the case of doubly linked list we are going to maintain another pointer which is the previous pointer, and this previous pointer is used to point to the previous node. Next thing we are going to do is we are going to create a variable, and this is a head pointer variable, and this is a global variable, and it is a pointer to the head node. So it is a pointer to head node. Next thing that we are going to do is we are going to create a function. So the first function that we are going to create is get new node function, and this get new node function is used to create a new node using a malloc function, and it will return a reference to that node. So the return type of this function will not be void, since it is returning a reference to the pointer. So we will write its return type as struct node pointer get new node function. In the get new node function we will write a parameter x, which is the data of the node, and this function will create a new node. So we are going to create a new node which has, or you can say which is a pointer to a structure node, and since this is a new node, and we will allocate it in the memory, so we are going to use the malloc function struct node pointer and the malloc function, and in the malloc function we are going to use the size of function, which returns the number of bytes our node is taking. So this is our structure node, and we have allocated this new node some in the memory. The next thing that we're going to do is we're going to assign the data of this new node as x, and this new node will also have the next and previous pointer, and since at this point we do not know what will be the next structure and the previous structure of this new node, we will assign it as null, because we cannot leave our pointers uninitialized. So we will have to initialize them as null. So we are going to assign the previous pointer as null also. And then since our function is returning, it will return a reference to the new node. We will write return new node, and you know that the return type of new node is struct node pointer. So remember that you will have to write the return type as struct node pointer and not as void. So this function get new node, it creates a new node and returns a pointer to it. The next function that we're going to create is the insert at head function, and this function will insert a node at head of our doubly linked list. So this function, since it is not returning anything, so we will write it as void. The name of the function is insert at head, and this function will take data, integer data, as the argument, and to insert the node at the head position, the first thing that we need to do is to assign this node and to allocate this node in the memory. And we know that we can do that by calling the get new node function. So instead of writing this whole lines again and again for insert at head function and then insert at tail function, we have just created this function, and we will just call this function to assign or to allocate the new node with the data x in the memory. So we will call the function get new node, and we will just provide the data inside this. So the next thing that we're going to do is we're going to write a check condition, and the check condition is if your head is null, that means that your if your head is null, where our linked list is empty, and so we are going to assign head as new node, and then we will just write return to exit out of this function. But if head is not equal to null, now if you want to add you want to insert a node at the head of the doubly linked list, the first thing that you need to do is you will have to assign the previous pointer of the head node to point to your new node. So this line assigns previous pointer of head node to new node. The next step is to assign the next of new node, the next pointer of new node, and this will point to head. So the previous of the head node will point to the new node, and the next of the new node will point to the head node. And finally we will change the head pointer, because we have added the node at the head of the linked list. We will have to change the head, and we will just write head equals new node. So now new node that you have added using this function insert at head will just change to this new node. So the head pointer will change to the new node. So these are the three steps to assign a new node at the head of the doubly linked list. And the next function that we are going to write is to insert a node at tail of the doubly linked list. And in this case also, since it is also void, we will again call the get new node function to assign the data to this new node. So we will create a struct node pointer new node, and we will just call the get new node function and we will provide the data to it, and this function will allocate a new node in the main memory. The next step that we are going to do is to just assign, we are going to create a temporary node and we will assign it as the head, and then we will traverse in the linked list because we want to insert at the tail. So if we want to insert a new node at the tail of this, we will have to move this head pointer to this tail position, and since we cannot change the head position, we will create a temporary variable which will be assigned as head, and we will move this temporary variable by using a while loop. We will assign temp equals temp next, and this line will run iteratively using the while loop until and unless this becomes null. And so the temporary variable, which was head, will move to this position, and then we will use this position to assign to our node. So we're going back to our C-line IDE and we will create a temporary function, a temporary variable, and we will assign it as the head. And so we are again going to write a check statement, which is an if statement. If head equal null, we are going to assign the head, we're going to assign the new node as the head of our doubly linked list. And then we will just write a return. The next thing that we are going to do is we are going to traverse to the tail of the linked list. So we are going to write until and unless the next pointer of the temporary variable is equals to null, we are going to run this while loop. And each time we are just going to assign the next of the temporary variable as new node. No, we are going to assign the temporary variable as temp next because we want to go to the last of the new node. So this while loop is used to go to last node. So the next thing that we are going to do, since we have now reached the last node, we are going to assign the next pointer to point to our new node, because we are going to assign this new node at the tail of our doubly linked list. And then we are going to assign the previous node of our new node to point to the previous, that means the temporary structure, which was the last node. So our new node, the previous pointer of a new node, will point to the last node. And you can see that it should work like this. Let's suppose we want to insert 8 at the tail. First we will assign the previous node of this new node to the last one, which is the temp, and we will assign the next of this new node as null, and the next of the temporary or the last node will point to the new node. So this is what we have done here in these two lines. So the next thing that we are going to do is to write another function, and this function is going to print our doubly linked list. And similarly, we are going to create a temporary node which will point to the head, and then we are going to traverse from one node to another using a while loop, displaying the data of every node. So let's create a print function here, and in this print function, first we will create a temporary node, and we will assign it as the head node. This should be struct, and then we will just write here, since we are printing our doubly linked list in the forward manner, I'm writing here forward, and then we will use a while loop, and in the while loop we are going to use the statement, this condition temp not equal to null, to traverse through our whole doubly linked list, and while traversing we will just display the data of the linked list, and then we will assign our temporary pointer to point to the next node. And this is how we are going to traverse through the linked list. Traverse through doubly linked list. So this is our print function. The last function that we are going to write is the reverse function, and this reverse function prints in reverse order. So we are going to display our linked list in the reverse order. So to do that, in order to achieve this goal, what we need to do is two things. First, we need to assign the head pointer. We will assign a temporary pointer as head, and we will have to move this temporary pointer to the last pointer, which is to the tail of our doubly linked list, and then we will use this previous pointer in a while loop to traverse backwards, and we will display after each and every iteration we will display the data of the node. So let's now write the reverse function. Since reverse function is also not returning anything, it is displaying our linked list. It has a data type void, and if we are going to create a temporary variable, just like this, we are going to create a temporary variable, and if this temporary variable evaluates as null, then we are going to return. And the reason why we are returning is because this is an empty linked list. So if our linked list is empty, or if the temporary node or the head node is null, so that means that our linked list is empty, so we cannot traverse in the backward order. The next thing we are going to do is we are going to use a while loop, and since we are displaying it in the reverse order, I'm going to write here reverse, And in the while loop, we are going to write a condition here, and the condition is that whenever the next pointer of the temporary variable is not equal to null, we are going to run this while loop. This should be curly braces. So every time we are going to run this while loop, at each iteration we are going to display the result, the data of the node, and then we will assign temp to point to the previous node, because we are going to we are going to display the linked list, the doubly linked list, in the reverse order. So we are not going to assign temp as next, but we are going to assign it as previous. So in this manner we are going to display our whole linked list in the reverse order. So now we're going to do the last step, which is our int main function. In the main function we are going to assign head as null, which means that we are just creating an empty linked list, empty doubly linked list in the starting, and then we are going to call the functions. Let's suppose I want to call the function insert at head, and let's suppose I want to add first at the head position. Then I will call insert at tail, and let's insert 5 at tail, and then I will call the print function that will print our linked list in the order 4, 5, and then I will call the reverse function to display the linked list in the reverse order. So let's run this program and see the output. Return 0. So let's run this program and see the output. So after running this program, you can see that there is some error in our program because it is not displaying the linked list in the forward manner. Our output should be 4, 5 and then 5, 4 in the reverse order. So I observed some errors in this code. The first error was that it should not be double equal sign, it should be a single equal sign. This was the first error. And the second error is in our void reverse function. So you can see that in this while loop we are traversing from we are traversing in the backward order using the previous pointer. So we are not going to use the statement temp next not equal to null. We will just write it as temp not equal to null. The second thing that we need to do is we will have to move the temporary pointer to the last node. Then only we can traverse backwards. So in this function we have not done that. So we will have to go to the last node. Then only we can traverse to the previous one. So we will have to move this temporary node to the last node, and in order to do that we will have to use a while loop again, and we will write the condition temp next not equal to null. Then we are going to make our temp as temp next, and this will make the temporary pointer, which was the head pointer, to point to the last node of our doubly linked list, and then we can display the data of our doubly linked list by using this previous pointer to display in the reverse order. So the errors are removed. So let's now run this program again and see the output. So you can see that after running this program the output is forward 5, 4, and then reverse order is 4 5. So this is the desired output, and that we have resolved the two errors. The error was in this reverse function, where we have to go to the last node, then only we can traverse backwards. And the another one was the double equal sign here. So in this way we are going to implement doubly linked list, and in this way we have written all the functions